Hello friends, welcome back. This is our fifth session of AIB input block, analog input block. We have generate the high and low alarm. Also we have generate power failure and overflow underflow alarm. Today we'll generate high and low alarm. Also we'll give a interlock, a bit, input bit, that high inhibit, low inhibit, high inhibit, that if you want to generate your alarm, you can make it as a false or true, or if you don't want to create the alarm but your program will be there in this block but your alarm will not be generated, that also we'll discuss here. Okay, to edit I will double click on that block, it will open the editor. Okay, to generate the alarm, high low alarm, just I will copy from that high to up to this one and just paste here. Okay, now here see the high limit, low limit, it already there, but it is just trouble because I will just copy paste here. I will write here and here I will write as a high alarm. Okay, high alarm. I will just copy this one and paste there too. Okay, and here I will write as double S. Okay, same way I will write here as low limit check, and here I will write double L, and here I will write that low alarm. Okay, and I will copy and paste here also. Okay, double L, here I have write that this one. Okay, that low alarm will generate, high alarm will generate, that time our timer will start. If you want to take another, sometime maybe high and high both will generate, so you have to take another timer. So here I will declare another timer in static. Below of the timer T1 2. Okay, if you want to take another time, that as a input variable we have declare TD, then you can write here. I will not use another time, so I will use same time, that PD preset time, TD as a preset time, and the timer will be T on 2. Okay, so T on 2 will start when high alarm temporary or low alarm temporary will generate. That time it will start and it will give output after that TD time expire, and when that T on time is on after this time delay, here I will write T2. Okay, and that T high alarm here, sorry, I will just copy and paste here also. So when this alarm generate and the time expire, that time this F5 not, it is F4 for high, this F4 internal or intermediate will generate, and this variable we have used here for holding purpose. Okay, so if that one is going low, it will hold by this one, and until the reset is not acknowledged, this will high, it will be high. Okay, same way F7, that is low alarm. When low alarm is activated and T2 timer is expired, that time it is held by this F7 intermediate and resetted by this one. Okay, so here you have to write F4 and here you have to write F7 for low alarm, and here you have to write F4 and F7. Now your high, low, all alarm is generated. Now we have to write another instruction code for accumulated alarm FT. Accumulated alarm, trip alarm, accumulated alarm, not for accumulated alarms. Here you can generate for warning alarm also. I will write only for trip alarm, FT. Okay, if F1 is also a trip alarm, power failure. So when F1 is generated, so F1 came from F1 internal. Okay, F1 internal, that F1 internal. Okay, or F2 internal for overflow, F2 internal, or F4 is for high alarm, F4 intermediate, or F7 for low alarm. So when that type of alarm will generate, that time F2 also generate. But for normal condition, if you want to make it true, so you have to give a not get before the bracket here. Okay, so it always be true. Okay, now if I go back, download after that code written here. Okay, here it is. Okay, here I will show by. Okay, now see, FT is false because there is a trip alarm. That's why it is false. It should be green if all the tripping alarm will normal condition. Okay, because it is high and high. Okay, both are activated, so FT alarm is generated. Okay, now I will give 15,000. Okay, 15,000 value is 1085. So if I give a reset, see, FT is true, all alarm also true. Now if I make it again false by giving a 2 to 20,000, 22,000. Now after 5 seconds our F5 means high on alarm. See the comments here. Okay, so this is a warning alarm. We did not code into our FT logic, so it is still true. So if I give the input value as 2500, so high alarm will generated, also high alarm will be generated, and as well as our FT also generate. Now one things that your alarm is generated because we have the code inside that block, so our alarm will generate. But if you don't want to create the alarm, if your high or high alarm, high or high limit is passed over by this out, that time if you don't want to generate the alarm, means your value F4 or F5 or F6 F7 is true. If you want to keep it as a true, don't want to make the alarm, so we have to give a input here. That input will decide you want to create alarm or not, and that alarm, that input name it as a inhibit. So for high it will be high inhibit, for high it will be high inhibit, low for low inhibit, low for low inhibit will not create the alarm for low. So here we will give 4 here high inhibit. Okay, this is boolean tag, and here high inhibit, this is boolean tag. Okay, and here I will give low inhibit, this is boolean tag, and low inhibit, this is boolean tag. That boolean tag will decide your alarm will generate or not. Okay, so here you have to, okay, suppose I want high alarm. Okay, suppose for if you here, if you don't want to create the alarm, so first I will want to, for normal case we want to create the alarm, and that will decide by the input high inhibit this bit. So if the value is false, okay, then you can write this code by this way also. Just write not, this will be like this also. If you give the high inhibit equal false, or if you write as a high not inhibit, then not inhibit means it is false, not inhibit means it is false, then this instruction will execute. But if the inhibit bit is true, then this will not generate, means this will as it is. Okay, so here we will write as else. Okay, else then our value is like this, and if our instruction is complete, our code is complete. So now I will download and I will show how it is work. We have written the code for high alarm. See, we have written the code for high alarm. Once it is okay, then we will just same way we will write for high, low and low. Okay, now we will check. So first here see F5 and F6 both are true. False means it is generated, alarm is generated. Okay, now I'll give here as 1200, sorry, 12,000 and the value is 866. Okay, now I'll reset. Okay, reset. Now our F4, F5, F6 all the alarm is true. Okay, now again I have give the 0 or release the reset. Okay, now if I give the value that is 25000, so our value is more than 1800, so it will generate the alarm high alarm is generated. See, F4 is false. Our comment, see the comment, it is high alarm. Our high alarm generated. So if you don't want to create the alarm, you have to give inhibit bit as a true. That means it is exclude. Okay, so first I will reset the alarm. Okay, it is 15,000, so it is 1000. If I give a reset, it will reset. Okay, now value is resetted, F4 is resetted to true. Now I will inhibit the high alarm, means it will not generate, means F4 will always be true. If the value is more than 1800, F4 will not change to false. Okay, you can give it as a 1 or you can give it as a true. Both cases are same. So inhibit is true means that high alarm will not take in action. Okay, it always be true. Okay, download. Okay, now I'll give the value as earlier, that 250000. So value is more than 1800, it is 1808. So alarm should generate as F4. F5 will generate because the value more than 1500, but inhibit is not true, it is false. So alarm is generated, but see, F4 is not generated because the inhibit bit is true. We have created the instruction, we have written a code that will not generate the alarm. So for all limit we will do same way. Okay, if not low inhibit, then it will execute like this. Else means inhibit is true, else means inhibit. Here if not inhibit means it is false, then it will execute like this. If else means not inhibit is true. Okay, so here then this one is false. Okay, and if our this instruction need to be closed. So here I will write as if int now closed. This int is closed here and this if is closed here. Okay, same way we will do here also. If low inhibit is false, equal false, you can write same way, no problem. Not inhibit or equal false, same thing. Okay, then here else this will be false. Okay, and if okay, same way I'll write for high alarm. If high inhibit is equal to false, equal to false, then this will execute, else it will execute like this one, and if close the if instruction that we have started here. Okay, so this is our all limit instruction. Okay, in next video we will create the code for forcing the output value, also for default value. Thank you.